The scariest thing about time is not that it can end. It is that it was never the same everywhere. April 10th, 2019, Messier 87. For the first time in human history, we saw the shadow of a black hole. Not the black hole itself, the place around it, the place where light bends, where space folds, and where time, seen from far away, begins to slow toward silence. But here is the disturbing part. You do not need to fall into a black hole to find broken time. You only need to climb a staircase, enter a cave, cross the wrong island at midnight, or stand on another world and ask your clock what now means. This is not fantasy. These are real places where time seems to behave differently. We trust clocks because they look honest. Their hands move cleanly. Their numbers change with perfect confidence. But a clock is not telling the universe what time it is. It is only reporting what time is doing where it stands. Move it higher and it changes. Hide a person from the sun and the body begins writing its own calendar. Move a country across a line and an entire day disappears. Send humans into orbit or machines to the moon and now has to be translated. Tonight on Lost Signal, we are not looking for time machines. We are looking for something stranger, real places where time bends, blurs, slips out of agreement and reminds us that the present was never universal. Boulder, Colorado. The Staircase Where Time Changes, September 28, 2010. At the National Institute of Standards and Technology, scientists performed an experiment that sounds too strange to be practical. They took two of the most precise atomic clocks ever built and placed one slightly higher than the other. Not on a mountain, not in orbit, just about 33 centimeters higher, roughly the height of a single step, and the higher clock ticked faster. The difference was almost impossibly small. Over an entire human lifetime, it would add up to less than a blink. But it was real. Einstein's theory of general relativity was not waiting in deep space. It was sitting on a laboratory table. This means time does not flow equally across Earth. It changes with height. A clock at sea level runs slightly slower than a clock on a mountain. Your feet age by a microscopic amount more slowly than your head. The terrifying idea is not that the difference is large, it is that there is a difference at all. Earth is not wrapped in one universal time. It is layered with invisible sheets of slightly different time stacked by gravity. Every skyscraper, every cliff, every aircraft, every mountain road is a quiet experiment in relativity. And in 2022, in the same Boulder research world, GILA physicists push this even further. Atomic clocks separated by about a millimeter could reveal time dilation at a scale smaller than a pencil tip. Time does not wait until reality becomes dramatic. It starts bending at the scale of a human body. 2. Skarason Abyss, the cave that erased the calendar. July 16, 1962, Skarason Abyss, Ligurian Alps, near the French-Italian border. A 23-year-old French speleologist named Michel Siffre climbed down into a cold underground cave with no clock, no calendar, and no sunlight. He was not trying to prove a myth. He was trying to find out what time becomes when the outside world stops telling you it exists. In the cave, there was no sunrise to reset his body, no sunset to close the day, no weather passing across a window, only darkness, damp stone, and a voice line to the team above. Siffre slept when his body wanted to sleep. He ate when his body wanted food. He called the surface when he woke, when he ate, and before he slept. but the team was not allowed to tell him the time. The result was not simple confusion. It was a collapse of human timekeeping. His body began to drift away from the 24-hour clock. Days stretched, memory slipped, counting seconds became unreliable. When the experiment ended after roughly 2 months, Cifre believed far less time had passed than the world above had actually counted. The cave did not slow the rotation of Earth, it did something more intimate. It removed the signals that allow the brain to believe in time. This is why caves are so unnerving in a time video. They do not bend space-time like a black hole. They bend the witness. In deep darkness, time becomes biological, and the human body is a clock that can lose its hands. 3. Svalbard, the town where morning disappears. November 14th to January 29th every year. Longyearbyen, Svalbard, Norway. In Svalbard, the polar night can make the idea of a normal day feel like a rumor from another planet. For weeks, the sun does not rise high enough to give the body its usual command. Morning is not the brightening of the world. Noon can feel like evening, and evening can arrive without ever being announced. This is not just darkness, it is the weakening of one of the strongest biological signals on Earth, morning light. Inside the human brain, the circadian system uses light as a daily correction signal, a silent update that tells the body when to wake, when to release hormones, when to feel alert, and when to prepare for sleep. But in the high Arctic, that ancient signal is disrupted for weeks. The clock on the wall keeps working. The clock inside the body starts negotiating. Sleep can drift, energy can flatten. The border between morning and night becomes something you manage instead of something the sky gives you. That is what makes Longyearbyen different from a dark room. A dark room is an interruption. A polar night is a season-long argument between technology and biology. People still live, work, laugh, eat, and measure hours with technology, but the body is receiving fewer ancient instructions. The community creates its own tempo. Lights switch on when the sun refuses to return. Meals, work, festivals, headlamps, auroras, and windows glowing against black mountains become the new clock. Here, time does not stop, it becomes negotiated, and that is a quieter kind of horror. Not losing seconds, but realizing how much of your reality was being stabilized by a star you barely noticed. You found the signal. Subscribe to Lost Signal. Leave your theory in the comments. 4. Samoa, the island that deleted a day midnight, December 29th, 2011. Apia, Samoa. At one moment, the calendar said Thursday. Then Samoa moved across the international date line, and the next day was Saturday. Friday, December 30th, 2011 did not happen there. No asteroid struck, no wormhole opened, no scientist activated a machine under the island. A government decision made to align the country with trade partners like Australia and New Zealand erased a date from civic life. It is one of the cleanest reminders that not every version of time is cosmic. Some time is human architecture. The Earth turned normally. The Pacific was still the Pacific. People still breathed, slept, ate, and aged. But the calendar, one of civilization's strongest illusions of order, skipped a square. Imagine being born on the missing date. Imagine booking a hotel night that never exists. Imagine asking what happened on December 30th in Samoa and being told, truthfully, nothing happened because there was no such day. That is the unsettling power of time zones. They are not natural laws, they are agreements wrapped around a spinning planet. And when the agreement changes, a country can appear to jump into the future overnight. 5. The Moon, the world that needs its own clock. September 12, 2024. NASA headquarters, Washington, D.C., looking toward the Moon. NASA announced work on a coordinated lunar time standard because the Moon cannot simply borrow Earth's clock forever. At first, that sounds bureaucratic, but underneath it is one of the most elegant problems in space exploration. A clock on the Moon does not tick at exactly the same rate as a clock on Earth. Because gravity is different. Because motion is different. Because the Moon is not just another address, it is another time environment. NASA has noted that atomic clocks placed on the lunar surface would appear to tick faster than Earth clocks by microseconds per day. That sounds tiny. But in navigation, communication, and landing systems, tiny errors become enormous distances. At the speed of light, microseconds are not nothing. They are geography. The future Moon will not just need habitats, power grids, landing pads, and oxygen. It will need its own definition of time. This is where the story becomes quietly apocalyptic. The first permanent off-world civilization may begin with a clock problem. Before humanity can build cities on the Moon, it must answer a question that sounds almost philosophical. Whose now are we using? Earth time, mission time, lunar time? The Moon is close enough to see with the naked eye, but far enough away that time itself has to be translated. 6. The ISS, the orbit where speed argues with gravity. November 2nd, 2000, low Earth orbit aboard the International Space Station. Since the first long-duration crew arrived, the International Space Station has been a permanently inhabited outpost, moving around Earth at about 5 miles per second. It circles the planet roughly every 90 minutes. In one day, the crew can pass through about 16 sunrises and sunsets. For a human body, that is already unnatural. But for physics, something even stranger is happening. The station is higher than Earth's surface, where gravity is weaker, which tends to make clocks tick a little faster. But it is also moving extremely fast, which tends to make clocks tick slower. The final result is a small relativistic tug-of-war between altitude and velocity. Every orbit becomes a negotiation between two versions of time. The effect is tiny for astronauts, not science fiction immortality, not dramatic time travel, but it is not imaginary. Speed and gravity are physically changing the rate at which time passes. The ISS is a warning label attached to the sky. It says, if you move fast enough, the future separates. Right now, the difference is small because the station is not fast enough, not yet. But the rule is already active. Every astronaut is a real-time traveler, just not by enough for the universe to look impressed. Some signals are not meant to be found, but you are still here. 7. Venus, the planet where a day outlives a year. April 29th, 2021. Goldstone, California, and Greenbank, West Virginia. After years of radar measurements, scientists refined one of the strangest facts about Venus. A day there is longer than a year. Venus takes about 243 Earth days to rotate once, but it completes an orbit around the Sun in about 225 Earth days. On Venus, the calendar year can finish before the day does. And the weirdness goes deeper. Venus rotates backward compared with Earth, so if you could somehow survive the pressure and heat, the sun would rise in the west and set in the east. A sunrise to sunset cycle would take about 117 Earth days. This is not relativity, this is not a black hole bending space-time. It is a planet showing us that words like day and year are not universal truths, they are local behaviors. A day is only the way your world turns. A year is only the way your world falls around its star. Change the world and the calendar becomes alien. Venus is horrifying because it makes time feel planetary, not personal, not human, not designed for us. On Earth we say tomorrow. On Venus, tomorrow is not a promise. It is a different kind of monster. April 10th, 2019, M87, about 55 million light years away. Now the loop closes. Because the most frightening place where time behaves differently is still the one we began with, the edge of a black hole. Near an event horizon, gravity becomes so extreme that time dilation stops being subtle. To a distant observer, an object falling toward the black hole would appear to slow down as it approaches the boundary, slower, fainter, closer to frozen. But from the object's own point of view, the fall continues. That is the nightmare inside relativity. There is no single master clock for the universe. There is no perfect cosmic present that everyone shares. There is only local time, fragile time. Time shaped by gravity, speed, light, darkness, biology, politics, and the world beneath your feet. A mountain changes time, a cave hides it, a polar night blurs it, an island can erase it, the moon requires its own version of it, the space station outruns it, Venus makes it alien, and a black hole makes it almost disappear. So the next time you look at a clock, remember this: it is not telling you what time it is. It is only telling you what time it is here, and somewhere near a boundary where light cannot return, here may already be gone.